Hello everybody. Today we have a great day. We're going to have an exciting day. We're going to talk about position. Now that's as exciting as it gets in physics. Position. What is position? Or as some people call it, location. Others call it place. Question is whether we're all talking about the same thing. Well, let's find out today. How do we do it in rational physics? Well, we start by defining our words. We have to have well-defined words so that we can communicate properly. The person can understand what you're saying, okay? And what is a definition? Some people say, well, what's the definition of a definition? Yeah, we have that as well. We had to do that because we had all these people asking questions. It's a limitation placed on the extent or usage of a word. You put a limitation. Now you can use it consistently, hopefully, right? Rationally, scientifically, okay? And first word you got to define, aside from definition, is the word object, because you can't do physics without an object. And we define it as that which has shape. Okay, so what's the subject today? We're going to talk about position, location, place, whichever, right? And so where do we start? We start at the word distance, okay? So we have to define what distance is. It's crucial, okay? And distance is simply the separation between two objects. As I like to say, distance is what lies between lengths, okay? Length is the continuous matter that you have between two surfaces of an object, okay? And distance is what separates two objects. Straightforward. Okay, what's location? Well, location is the set of distances. You have separation from one object to another, and one object has separation from every object in the universe. You can take, for example, an atom and say, well, this atom has separation from every object in the universe, from every atom in the universe, okay? And so that's the location of that object. Because we don't unroll measuring tapes in physics. That's mathematics, okay? Mother Nature only deals with qualitative stuff. She just knows for sure how, that there's separation between the Earth and the Moon, and between Jupiter and the Moon. And she knows that Jupiter's a little farther away than the Earth from the Moon. They have different separations. That's it. She doesn't go in there with a measuring rod and say, let's see how far away it is exactly. No, she doesn't care about that. Okay, she's only qualitative. And that's what physics is about. You have to explain mechanisms, and for that we do not need numbers. And a lot of people have problems with that because no one has ever dealt with physics in the way we deal with it here. Okay, okay, so that's location. From there we move on to exist. Why? Because physics is the science of existence, and object requires a location in order to exist. If God wants to exist, he's got to have distance with respect to the objects that are out there, with the remaining objects that exist. Okay, and that's it. Very simple, very straightforward. We're done. You know, as far as location is concerned, just a set of distances. Now, those are not the notions you'll find out there from mathematics. And where did the mathematicians get their cues, or where did they start? Where did they get all their notions today, that they have today? They got them essentially from Aristotle. That was the starting point. Maybe there was someone before them, very surely. But we have a book called Physics, written by Aristotle, where he kind of synthesized either the notions that the Greeks had in general, or his own notions, whichever, we don't care, but the point is that's the starting point for at least Western civilization. That's where mathematics grew, okay? Mathematical physics, so-called science. Okay, so what did good old Ari have to say about position? Let's start at the beginning. He synthesizes this, by the way, his notions, in his book 3 of physics, okay? And here it is, okay? This is our starting point. And he says, the physicist must have a knowledge of place as well as of the infinite. Well, I don't know about the infinite, but place, if I think I know what he's going to talk about. Sounds about right. Yeah, we need to know what location is. People, in mathematics, they call it position, but they're referring to someone else as something else, as we'll see today. Okay, whether there is such a thing, okay, as place, the manner of its existence, place exists. Okay, that's what he's going to talk about, and what it is. Okay, if it's a what. Okay, because all suppose that things which exist are somewhere. I love that. He said it, but he didn't know what he said. And anyone who read Aristotle and read that statement has no idea what he said or how important it is. Let me read it again because it's ultra important. Because all suppose that things which exist are somewhere. The non-existent is nowhere. Well, he said it almost perfectly, but he never realized how important it was, and nobody ever paid attention to that statement. Yeah, exist means an object that has location, and if it doesn't have location, it doesn't exist. And that's very important because, you know, you have atheists and agnostics and theists talking in circles, and they never defined or understood the definition of the word exist, and there you have it. If they would have read that statement and understood how important it was, they would have saved themselves hundreds of years of debate, acrimonious debate, okay? And because motion, in its most general and primary sense, is a change of place, which we call locomotion. Change of place. Well, I got a problem with that already because change is already motion. And motion is change. You can't have change without motion. You can't have motion without change. So they're synonyms as far as we're concerned. There is no difference between change and motion, and you can't use a synonym to define a word. So that shows, again, how important definitions are. In fact, his definition is still what everybody uses out there. They say, oh, it's a change in place and location or whatever. No, change is already motion. We say it's two or more locations. That's what motion is. That's different than saying it's a change in place. Because again, if you say change in place, are we saying that what changed? The object moved from one place to another, or was it the place that moved? Okay, maybe it's the place that moves, who knows? Okay, but Ari immediately starts with a disclaimer. That's quite interesting. I had to read this because I thought it was interesting. He says, the question, what is place, presents many difficulties. An examination of all the relevant facts seem to lead to divergent conclusions. So everybody's got a different opinion of what they think place is, right? Moreover, I like this part. We have inherited nothing from previous thinkers, whether in the way of a statement of difficulties or of a solution. I hear you, Ari. I've inherited absolutely nothing, at least in terms of definitions, from the previous generations. Nothing. No one has ever defined words. No one. And scientifically, right? And, you know, it's funny because, who is it? Isaac Newton, he said he stood on the shoulders of giants. Well, he was lucky. I stood on the shoulders of dwarves, mental dwarves. Okay, no one defined any term that's important to physics in the last 10,000 years. So it's not like I reinvented the wheel. It's that the wheel was never invented. I had to invent the wheel. I had to construct it nail by nail. Okay, so what is place? Let's see if we can get to the bottom of it with Mr. Aristotle. Here he says, the typical locomotions of the elementary natural bodies, namely fire, earth. Remember, they believed in all this stuff that there were only 4 elements: earth, wind, and fire, and then the 5th element there, quintessential. Okay, fire, earth, and water, right? And the like show not only that place is something. He's saying place is something. Of course, he never defined what something is. He's saying, but place is something. That's interesting, because I would say place is not something. I think it's more like nothing, the opposite of something. But let's continue. But also that it exerts a certain influence. So here he's saying that not only it's something, but it bounces against the somethings, or has some influence, some interaction with something. These are the notions he had, okay? This is made plain also by the objects studied by mathematics, okay? And he says, though they have no real place, at least he acknowledged that, they nevertheless, in respect of their position relatively to us, have a right and a left. Do they? You know, I just had a fellow who wondered about the number line. And, you know, you wonder about that. Here I have the number line. You say, well, yeah, it looks like it's got direction. It's got a little arrow there at the end, you know, engine arrow, as I call them. And so it looks like the number line has direction, right? But actually, you know, this is, you know, numbers have no direction. You know, number is just a number. You're counting. That's what number is. Okay, and here we have the definition. Again, we work off of definitions. And number is just the verb to count. It's not a noun. It's a verb. You can't you can't make a drawing. You can't make an image of the word number. Yeah, you can put a 5, you can put a 6. But I'm not talking about that. I'm talking about number, the word number. You can't illustrate it, because the word number is not an object. You can't point to the word number, to whatever number represents, okay? Because it's a concept, and it's a verb, to count. What is it? The number of times that you move your finger up and down, okay? It's, as I say there, naming each shake of the hand. So you go 1, then you say 2, you say 3, and you give them names to every time you shake your finger. That's what number is. And they made a big monster out of number, right? Because today they have all these notions that they've developed in mathematics, and all they have to do is figure out what a number is, and all it is just counting, the verb to count. Okay, let's see if I had it here. Yeah, there was one more issue there. The theory that the void exists. He's talking about the void existing. He says it's got to. He said exist. What was exist? Exist. It has to have location. If it doesn't have location, it doesn't exist. He's saying that the void exists. The void has place, as he called it. Okay, whatever place is. So far, we still don't know, but that's important that he stated that, because he's saying the void is not only a thing, but it exists. Very interesting. Involves the existence of place, for one would define void as place bereft of body. You get rid of the body, what's left? That's place. That was his notion, okay? And yeah, here we have, he continues, he says, these considerations then would lead us to suppose that place is something distinct from bodies, okay? And that every sensible body is in place. In other words, you have a place and you have a body, and the body occupies what he calls, what he's going to call, or what he's going to be analyzing here, what he calls place, okay? It has 3 dimensions. Place has 3 dimensions, because, you know, you can't have 2 dimensions or no dimension. You have to have some kind of dimensions in that whole so that a body can occupy it. This is the sense he has, okay? Length, breadth, and depth. Again, breadth and depth are vectors. They have nothing to do with length, and length has nothing to do with these vectors. Length is a dimension. It should be paired against width and height. Okay, those are the 3 dimensions. Breadth and depth and elevation, they're vectors. Okay, the dimensions by which all body also is bounded. Okay, but the place cannot be body, for if it were, there would be 2 bodies in the same place. That's his reasoning. He's saying place is not body, because you would have 2 bodies in the same place, and he's saying that that can't be. Another body occupies the place when the first body leaves. That's his notion of what place is. That's the notion he's going to use. So we still don't know what place is, but he's already telling you not only what he thinks it is, he's giving you some hints so that you can look at that and say, okay, I see where he's going with this, right? And okay, so here he gives you the notion. Essentially, he's saying, look, you have a thing, in this case a box, a cube, whatever, and you pull it out, and what you leave behind is this place. And place is not the same thing as space, because place is a three-dimensional whatever that the body leaves behind when it leaves, and so it's like leaving a hole in space. Okay, that's his notion of this. Keep that in mind. That's where he's headed. Okay, he's saying place is something, a standalone thingy, whatever that thingy is. Okay, and the funny thing is, to this day we still have these notions, a lot of these notions. Okay. Okay, so he tries to summarize it here. He says, there are four things of which place must be one. Okay? One is the shape, the matter, some sort of extension between the bounding surfaces of the containing body, okay? Or this boundary itself, if it contains no extension over and above the bulk of the body which comes to be in it. Okay, so he says, these four... place has to be one of these four things. Okay? It's got to be one of them. And then he rejects three of them. Here it is. Put it on the side so you can compare it next to each other. Form is the boundary of the thing. The place is the boundary of the body which contains it. So he's going to reject the first one, shape. Okay? Matter is neither separable from the thing nor contains it, whereas place has both characteristics. That's his reasoning for rejecting matter. And the last one there, if extension were such as to exist independently and be permanent, there would be an infinity of places in the same thing. That's how he rejects extension. And so he goes with his reasoning one step further and says, okay, what's left? Okay, essentially that's his reasoning here. Let me get this one out of the way. Okay, and so he says the following. He says, if place is none of these, of the three, neither the form, nor the matter, nor an extension, place necessarily is the one of the four which is left, namely the boundary. Okay, so it's the outline, the perimeter, any way you want to look at that, of the containing body, at which it is in contact with the contained body. Okay. So he's saying essentially it's going to be the perimeter, the boundary, the outer surface, you could say. Any of those words would fit in there just fine. That's his notion of it. Okay. Does he give us a definition? Well, no, that's his notion. That's it. That's as far as he goes as far as a definition. Okay. But then he adds the following. He says, what then after all is place? Okay, what is it, dear Ari? Could you please tell us? The answer to this question may be elucidated as follows. He says, place is what contains that of which it is the place. Okay, place contains the something that's in the place. Okay, contains it, essentially. Place is no part of the thing. Two separate things, the thing and the place, right? The immediate place of a thing is neither less nor greater than the thing. Okay, so it's the same size, I guess. That's what he's saying. Place can be left behind by the thing and is separable. So again, you know, you take the box, you leave a hole. So place is the hole, not the box. Okay, it's two different things. All place admits of the distinction of up and down, and each of the bodies is naturally carried to its appropriate place and rests there. Okay, and this makes the place either up or down. Okay, so he's got another one. I just didn't put it in there because it was not very relevant at all. And so again, I'm looking for a definition, and I'm not going to get anything beyond boundary, okay? Because when he goes next, he says, place will be explained in this way. He's going to explain what place is instead of defining it. He gives you already the notion boundary, and you got to, that's your best definition, okay, or what he's saying. But here he says, there is no necessity that the place should grow with the body in it, okay? So they both have the same size, okay? Momentarily, at least, while the body's in that place. Nor that a point should have a place. A point? I thought a point was zero-dimensional. Well, what kind of point has a place? Okay, but whatever. We have four-dimensional space-time, an event. What is that? A point in space-time. Okay, so that's... there you see where this comes from. Nor that two bodies should be in the same place. Okay, so two bodies can't be At least they understood that. You know, you got to take one body out before another one occupies it. When he's talking about this, he's referring a lot to air and water. Okay, keep that in mind. He's saying, you know, when water moves out, air fills that same space, that same hole. So Aristotle did not believe in nothing. He said there is no such thing as nothing, because as soon as a body moves, something takes its place. Okay, that place thingy, that shape, that's all it's got. It's that outer boundary, that perimeter. Okay, no, that place should be corporeal, a corporeal interval. So it's devoid of matter. It's devoid of a body. Okay, that's what he's saying. For what is between the boundaries of the place is anybody which may chance to be there, not an interval in body. Okay, so he's saying that, you know, you don't have nothingness in there. There's no interval. I guess they also had this notion, it's not apparent, but it's implied, I guess, that all bodies were kind of made of a single piece, because if he's going to talk about there not being an interval, what is he talking about? He's saying there's no little holes in this object that's all made of matter. There's no holes in there. It's like a single piece. You know, you would think that that's going through his mind if he's going to make that statement there. Okay, place is also somewhere. Okay, I thought place was somewhere, but he's saying here we have a place that is somewhere. Okay, not in the sense of being in a place. Okay, hopefully, right? But as the limit is in the limited. Some fancy wording there. Okay, the limit is in the limited. Okay, whatever he meant by that. Each kind of body should be carried to its own place. Okay, carry it to the place. For bodies which are united do not affect each other, while those which are in contact interact with each other, on each other. Okay, so he's saying if they're, united. Okay, if they're united, I guess they don't affect each other because, you know, they're one, essentially. I guess he's saying there's no separation between them. Who knows what he had in mind there. But the point here is the notion of place. Place, he says, it's a boundary, okay? And you might say, well, what is the relevance of this today? Well, yeah, we have, see, because if place is a little boundary that's devoid of an object that occupies that, if there's such a thing as place all by itself, standalone, you know what he's talking about? He's talking about a hole in space. And yeah, we've got that notion today. It's known as a black hole, you know. And here you see a notion, you know, of that's supposedly space and the stars and everything, and you have a black hole in there. Except that this is a misrepresentation of a black hole. Okay, it's a misrepresentation because, you know, that hole, as far as I can tell, I don't know if you reach a different conclusion, but it looks like it's at least two-dimensional. It's got a diameter, it's got a radius, it's got size, it's got everything of an object, which is essentially what Aristotle said. You know, he says, what is a place? A place is that which has this boundary or this shape, the outer shape, right? But it's devoid of an object. And that's what a black hole is. It's a something, supposedly, right? It's got size, and it's within space, which is something else. Okay? But in fact, they made a picture of that. You know, they claim that that's a black hole, okay, in space. And again, you can see it's two-dimensional at least. For sure, it's three-dimensional, okay? But what is the problem with that? Well, the problem is that black holes are zero-dimensional. They have no size. There is no diameter, no radius in a black hole. So we've got a zero-dimensional hole in nothing, in space. Here you have Mr. Stephen Hawking. He puts in his book, A Brief History of Time, which was a bestseller, right? Big seller. And he says this in, I think it's chapter 6. Chandrasekhar, he was an Indian fellow who came to study and work in England, right, in the early part of the 20th century, and won the Nobel Prize eventually. Says, calculated that a cold star of more than about 1.5 times the mass of the sun would not be able to support itself against its own gravity. Chandrasekhar limit, that's what he calls it, or that's what it's known as today. Eddington, he was a supervisor, a Chandrasekhar supervisor, refused to believe Chandrasekhar's result. Eddington thought it was simply not possible that a star could collapse to a point, meaning nothing, zero-dimensional. We're not talking about point being located with 2 coordinates or 3 or 4. No, we're talking about a 3-dimensional object, a star, a sun, collapsing until it disappears completely matter-wise. It crushes all matter out of existence. It has no structure. That's what he's talking about. And he, just in case you missed it, he says, Einstein himself wrote a paper in which he claimed that stars would not shrink to 0 size. No doubt about it. They're talking about 0 size, 0 volume, 0 diameter, 0 radius, the whole works. Nothing there except mass. Okay, it's a pinpoint mass, if you want to think of it that way. When he was awarded the Nobel Prize in 1983, it was for his early work on the limiting mass of cold stars. Chandrasekhar had shown that the exclusion principle could not halt the collapse of a star more massive than the Chandrasekhar limit. Yeah, a black hole is 0-dimensional, and not everybody's aware of that. In fact, I was on JFG's, Gariepi's show in Canada a couple times, and I told him this, and he said, well, no, it's not true. They don't believe, he believed that the mathematicians don't believe that it's 0-dimensional. And here Chandrasekhar won the Nobel Prize for it. If people would read some of these things, they would not talk nonsense. They would say, they would realize that what the mathematicians are saying, and that's that a black hole has no size. There's nothing there except mass, a concept, weight. It's like they got rid of the elephant and what's left is his 5-6 tons, whatever. That's what a black hole is. That's what these people believe in, and that's what they say, moves stars around. And of course, you can't draw 0-dimensional whatever, but they took a picture of it, and it went around the world. Everybody said, "Oh, they proved its existence." No. First, please define what a black hole is. That term, I need to know what that term means before you go look for it out there or take pictures of it. Okay. Okay, so what happened with all these notions that good old Ari had? Well, the mathematicians, in a sense, use it for like the black hole, but that's not the notion they have. They developed a different notion, which probably started with Descartes, René Descartes, in the early first half of the 17th century, and that's the Cartesian coordinates. Okay, and so if you ask all the mathematicians today, all these guys are dead, but all their disciples are still around, and they define what a position is, which is more or less what came after the Aristotle's place. And again, I think it started with Descartes. I haven't been able to trace it before then. It's the Cartesian coordinates. Okay, he came up with that. So what is position? A Euclidean vector. Vector is motion. Okay. So we're talking about position, which is a static concept, and they say it's a Euclidean vector, motion, right? That represents the position of a point P in space in relation to an arbitrary reference origin O. Okay? So what are they talking about? Well, they're talking about a little arrow that extends from point O to point P. That's a position. Here's an illustration of that. Okay, here you'll see it. That's essentially what they're saying. They're saying, look, you got a point O, and it extends to a point P, okay? And in this case, A, doesn't matter. And so what are they talking about? They're talking 2, 3. What is that? Well, you go 2 on the x-axis, 3 on the y-axis, and you reach your position. your position with respect to, oh, what are they talking about? They're talking about motion. What they're talking about is, how to find a treasure chest. They're giving you instructions, a map. This is what they're talking about. They're saying, look, you want to find the treasure chest, you got to take 2 steps to the right and 3 steps up north from the tree, and that's where the treasure chest is. You can dig in there and you'll find it. So they're giving you instructions. That's what they're saying position is. Position is a set of instructions to find a treasure chest or whatever you want to locate, position. And from there they developed also, keep this in mind, they developed the notion of the frame of reference. What is a frame of reference? Well, imagine in space, you've got a big stake, you hammer it into space, I guess, put a corner there, and from there you can, gauge the motion of all the planets, all the stars, everything you want, because you put a stake on the ground or in space, right? This is the notion they have, and it all comes from this, because it's all mathematics, but very little to do with the qualitative universe in which Mother Nature swims, right? Okay, and so how is that different from motion? Well, I don't see any difference whatsoever, because here's their definition of motion of the mathematicians. Motion is the change. Again, motion is change, so you can't use a synonym. Motion is the change in the position of an object over time. So you need to define time before you can define motion in mathematical physics. Okay, that's the first one. The second one is they say it's a change in position. So you have this first arrow, it took you to A, then you got the second arrow, it took you to P or whatever, right? And then that change in location, in position, in place, that's what they call motion, okay? And when you look up change also, a difference in the state of affairs at different points in time. Sounds a lot like motion. So we have a synonym on top of synonym on top of synonym, aside from the fact that it's like you need the word time. You need to find out what time is before you can define motion, because it's part of the definition. And you go to time and you're going to find the word motion in there. So it's like it's a circular argument. Time depends on motion. Motion depends on time. And like I showed last time around, no, they're not synonyms. There's a difference. Time requires memory and requires 2 motions. You compare 2 motions, that's why you require memory. Okay. Anyways, do we know what place is? Well, place is just the hole left behind by an object when it leaves. And that's more or less what a black hole is, because when the sun or the star, right, crushes out of existence, all matter, all architecture out of existence, as they say, crushes it, no more architecture, no more structure. What's left is a black hole. What is a black hole? It's a hole, in fact, in space-time, but it's like Aristotle's place. It's just a hole in space, okay, because space is different than the hole, and it's where, in this case, a star used to be. The star is no longer there. The star is gone. What's left behind is the hole, but this hole is zero-dimensional these days. See, I don't think Aristotle was thinking of zero-dimensional holes, but right now we have zero-dimensional holes, and that's what people believe in. They believe that, through a lot of propaganda, a lot of commercials, and spreading of the word, the catechism, people believe that there are black holes out there, some kind of body which is not a body, a zero-dimensional body which moves stars around. You can't see it, but they took pictures of it. Okay, and so yeah, Aristotle started on the wrong foot, and he led everyone that came after on the wrong foot. Okay, because now we have this notion of place, which I don't think anybody uses. What do we call that in rational physics? We call it position. Position is the site occupied by an object. In other words, the object itself. That's what position is. You don't leave position behind when you move. You don't leave a hole there, as Aristotle thought. No, when you move, there's no hole left behind. But see, Aristotle had to explain why there's no such thing as nothing. He didn't believe in nothing. And so he says, when you move it out, something else occupies its place. What occupies that place? It could be water, it could be air. He thought of the four elements. Maybe it was even the ether, you know, the fifth element there. Maybe that occupied the space, the place, okay? But he made sure that you understood that that hole is different than space. In other words, that was a hole in space. And that's the same notion these people have for the black hole. Anyways, with that, we're going to continue along this line of criticism of poor old Aristotle next time around. So we'll see you then. Bye-bye.